Hey guys, long time no see. Took a little break from making videos, but kept exploring languages. Was playing with Nim a little bit, and I found some interesting things that I wanted to share. Been doing some Leetcode, mainly in Python, because I feel like it's the best for kind of drafting algorithms. And from there, I moved to testing the speed with backtracking of different languages. And this same approach, which isn't highly optimized, I implemented in a few languages, and the one that interested me the most was Nim. So I figured I'd make a video on a simple backtracking permutation function. So let me go through it really quick. I won't do a live coding, but I'll do a live comment session, I guess. So to start off, we have this permute function that takes an integer and takes nums, which is a sequence of ints, and returns a sequence of ints. And the reason we can't use an array here is because we have to know the length during compile time. There might be a way to do it, but because I'm appending to ants here, which is the answer sequence, I couldn't find a way to get it to work because the length of nums would have to be known at compile time. So to simplify anything, again, very unoptimized, I just decided to use sequences here. So instead of a map, I'm using an array of booleans to track if a value has been visited. So let me do this here. So indices of nums. And now we are going to iterate over nums to populate visited. And here, one of the nice things about Nim is that it does allow closures. So I'm going to create some local variables to the permute function that this BT procedure can use and manipulate. And what I find very interesting is that Nim compiles down to C, JavaScript as well, which I'll show later. So even though it's compiling down to these languages that do not support closures, it does itself. And I think that just shows how ingenious the Nim compiler is and how it's able to optimize things, even if they're written in an unoptimized manner, such as this. So we've got our current permutation. So this is a function with a closure. I don't know if you could call it a closure function. So let's test the base case here. So if the length of our current permutation is the length of nums, then we add it and return. And now we want to iterate over all of our options. So our options are all of the indexes in nums. And now we have to check if it's not visited. So we haven't made choice I. Mark it as made. Add it to the current permutation. Now we recurse. And now here we undo our choice. And we call this closure function here and then return the answer. And because this isn't optimized, I believe the runtime is close to factorial of n, so it gets very, very slow very quickly. Even with only 10 numbers in our sequence of nums, it will slow down really fast. So this allowed me to kind of test different languages with a basic solution for permutations, one that gets accepted with Leetcode and performs relatively well, I think above 80% for most of the languages I tested in. So even though it's not optimized, it is still above average in performance. So if I look at Nim, I was really surprised. It was actually the fastest language. I got it running roughly 1.3 seconds. Python naturally was the slowest. at around 9 seconds, but still not drastically slower than these other languages, which was surprising. Golang, I was really impressed with the performance, and it was very easy to write. C++, out of all the languages I'd say I probably know C++ the least. And I think that's reflected in the performance of this. But what was surprising is on Leetcode, it said that the performance was in the, I think, like top 99%. So it might just be something with my machine or my local compiler, but it performed not the fastest, second slowest, but very close to Luajit, which again, I was surprised at how performant it was. But still, the most remarkable thing to me was just how fast Nim was. So if I go over here, I'm going to show how to get this working with Leetcode, because even though you can test a few solutions locally, just to ensure that you're solving a problem completely, making sure all edge cases are tested, it's really helpful to have something like Leetcode, to have an online judge that you can check yourself against. So if I look at permute here, you can see that I've run this with, or I've written this with a little addition. I added this tag here, and what this does is when I compile my Nim code to JavaScript, it will preserve the name of all these functions, so I don't have to worry about like gobbledygook spaghetti code. Another thing you want to consider when you're compiling to JavaScript is you do not want to have any test functions here, so I commented them out because when you submit to Leetcode, you're not going to be testing anything. You want it to just be the function. So now if I open up my terminal, you can see I have backtrack.nim right there. So I'll do nim js backtrack.nim. There we go. So now I've built everything out into JS. So if I look for backtrack.js, you can see it looks like a lot of gobbledygook, but we do have the permute function right here. So just take all this code and we can paste it into Leetcode right here. You can see permutations. We'll do a run really quick just to make sure everything's working. Perfect. And now we'll submit. And we can see that the performance is decent and the memory usage is decent as well. Again, it's not optimized, so it's not the best. And we can see here some of the previous solutions I did. Again, very interesting how C++ was extremely quick on Leetcode, but on my local machine, the performance was not great. And again, that might just be how it's handling that recursive function. Maybe the Leetcode doesn't test with up to 10 integers like that. But what's really nice is we can use an online judge to make sure that our solutions are valid. So if you really want to brush up on your algorithms with Nim, just compile it to JavaScript and then use Leetcode to make sure you're getting every edge case solved and that there isn't a huge performance sink. But again, if there is, it might be how it's compiled. But interestingly, I found that the compilation does a really good job of optimizing. One last thing that I'll check is if I go back to my terminal, if I do -d release, it might speed up the JavaScript code. But again, I'm not sure. I don't believe that that changed. So let me just run it one more time here and then see if anything changed with that. Do one more. Let's run this, make sure it's still working, and then we'll submit and see if compiling it with the release flag makes any change. I don't think it will make much of a difference. Yeah, pretty much exactly the same. So no need to add that release tag, just compile it to JavaScript and send it on Leetcode. Thank you guys. Let me know if you have any questions. I don't think that the code for this solution is on my GitHub, but it's fairly simple. Feel free to try it out yourself. Let me know if there's any problems on Leetcode that don't work with the compiled JavaScript that you believe should be working. Thank you guys. Have fun. testing out new languages. I'll try to do the same, and I'll try to start making some more videos. Thank you.